right, here we are with lesson 7C. There is no lesson 6C in this unit, so our next lesson is 7C. Today we're going to be solving systems by another process called elimination. Today is just day one, so you can see what it's like. It'll take us about 3 days or so to really explain this process. Remember, this is just another method in solving systems. And remember, when we solve systems, we're looking for a point that's in common for both equations. So remember, when we solve, our answer is going to look like a point. So today's process is called elimination. And so what we can think of is this truth, this thing we know to be true. We can add equations and answers together, and they still come out equal. So what I mean by that, if you can see this, I'll zoom in. I do want you to write that stuff down. So what I mean by that, if we had regular old equations, 1 plus 9 is equal to 10. 2 plus 5 is equal to 7. So these are two separate equations. But what we know to be true is if we add these answer parts together, they'll still come out equal to the problem parts. So what this would look like is 3 plus 14 would equal 17. So we know that this is true. 3 plus 14 is 17. So what this tells us is we can actually add together the add-ins and add together the sums, and it still comes out to be true. It still comes out to be equal. So what does this look like with x's and y's? Well, here's what it looks like when we have x's and y's. What we're going to do is make sure that everything is lined up with its like term, and we're actually going to add the add-ins and the sums, and it will still come out equal. But what we want to have happen is so let's go ahead and write this down. It says using the elimination method, we need a variable to go away so we can solve. So when we add these expressions together, we want either the x or the y to go away so that we can solve. Now I know this is weird, but let's see how this works. Let's look at number 1. So number 1 gives us 2x plus y equals 6. And 3x minus y equals 4. So we want to look for when these are equal to each other. Well, right now we don't have an x equals. We don't have a y equals, so we can't use substitution the way it looks here. It's also a little bit tricky to graph these. So we don't want to really graph to solve this either. So in this process, using the elimination method, what we're going to do is add the equations to each other. We're going to add them together. So just like I did up here, 1 plus 2 is 3, I have like terms here. 2x plus 3x is 5x. Up here, like I did 9 plus 5 is 14, I would have positive y minus y, or 1 plus negative 1. Well, that's going to be 0 y's. I'm going to bring down my equal sign, and then on this side I have 6 plus 4, which is going to be 10. So this is still true. This is still a true statement. It's using the equations. We're smashing these equations together and smashing together their answers, and it still comes out true. Now, what do we notice? Well, this one has 0 y's. And we want this to happen because 0 times anything is 0. I could rewrite this as 5x equals 10. So what happened here was the y's got eliminated. The y's canceled out. And now what I have left is something that's very easy to solve. I just have to divide both sides by 5 now to get that x is going to be equal to 2. So I already have part of my answer. I can already see x will equal 2. Again, I want you to highlight this because I want you to see what happened here. We added these together and the y's eliminated. The y's went away because they were opposites. They were additive inverses. And so they cancel out. That's what we want to have happen. If one of the letters cancels out, we can solve for the other. Now that we know x is 2, we can apply that to either one of these equations. I'm going to look at the numbers we have here, these coefficients. So I know x is 2. I'm going to be plugging that in. But what would I have left over? Well, in this case, I would have a positive 1y. In this case, I would have a negative 1y. I know that negatives sometimes cause issues, so I'm going to plug into this top equation. That's the one I see as easier. The top equation was 2x, so I'm going to just point an arrow so you know where this came from. 2x plus y is equal to 6. Well, now we know what x is. We know x is equal to 2. So I'm going to write 2 times 2 plus y is equal to 6. 2 times 2 is 4, so 4 plus something is equal to 6. Well, what is that something? Well, y must be 2. So I'm going to fill in that the y is 2. Now I know x and y. I know what my answer should be. I'm going to check it. To check, I'm going to zoom out a little bit so that you guys can see both parts of this. All right, so I'm going to check 2, 2, where x is 2 and y is 2. I have to check for both equations. So equation, let's call this equation number 1. Equation number 1 was 2x plus y equals 6. I'm going to fill in what I know for x, which is 2, what I know for y, which is 2, and together all that should equal 6. Well, 2 times 2 is 4, plus 2 should equal 6, and 4 plus 2 is 6, so it checks out for the first equation. But it has to also work for the second one. So equation 2 is 3x minus y. 3 times x minus y should equal 4. So that means 3 times my x is 2 minus my y is 2 should equal 4. 3 times 2 is 6. Bring down the minus 2 equals 4. And 6 minus 2 is 4. So that works out for the second equation as well. We need to be checking all of our answers. But this is our new method. So this is elimination. We're going to add the equations together. So let's write a note about that. Add equations together. Add equations, or in other words, combine like terms. Combine like terms. Add equations, and hopefully one of them will cancel out. I'll show you what to do if one of them doesn't cancel out, because we can always manipulate these equations how we want them. Kind of like changing it from standard form to slope-intercept. Same idea. All right, let's go ahead and look at number 2. Again, we're going to add our equations together. We're going to combine like terms. This time I see 1x plus negative 1x is going to cancel out. I get 3y plus 1y is going to give me 4y. And 5 plus 3 is going to give me 8. So I get 4y equals 8. Easy step now. I'm going to divide both sides by 4. And I've already found that y is equal to 2. Remember, we need an x and a y, so now we plug it in. I see a whole lot of positives in this top one, so I'm going to choose to use the top equation. So I'm going to rewrite this one. X plus 3y equals 5. I now know that y is 2, so I'm going to replace the y, and I'm going to replace that y with a 2. So that means x plus 6 will equal 5. If I subtract 6 from both sides, we get that x is equal to negative 1. And we're already there. Now we check our answer. We're going to check for equation 1. Equation 1 was x plus 3y equals 5. If I'm saying my answer is negative 1, 2, that means I should be able to fill in negative 1 for x plus 3 times 2, and that should equal 5. That means negative 1 plus 6 should equal 5, and it does. So that checks out for the first equation. Now equation 2. Equation 2 is negative x plus y equals 3, which means negative, let's see, my x is negative 1, so negative 1 plus my y is 2 should equal 3. Well, what do I get here? Negative 1. The opposite of negative 1 is positive 1. Plus 2 equals 3, and 1 plus 2 is 3. So that works out. There's my answer. Okay, let's try that again. Again, this process of elimination means we add the equations together. Negative 2x plus 2x is 0x, so it cancels out. 5y plus 2y is going to be 7y. Negative 10 plus 10 is going to be 0. But it's okay on this side because that wasn't eliminating another variable. That's just a 0. So this tells me 7 times something is 0. Well, the only thing I would have there is 0. So that tells me the y is 0. Now we just plug it back in. Again, the one that has mostly positive numbers is usually the one that I do better with, that you guys do better with. So I'm going to rewrite that second equation. 2x plus 2y equals 10. I now know that y is 0, so I'm going to write 2x plus 2, open up that spot for y, and I'm going to fill in the y now with 0. That means 2x plus 0 is equal to 10, which means 2x is equal to 10. And when I divide by 2, I get x is equal to 5. So that means the point where these lines cross is going to be at 5, 0. Now we check. Equation number 1 was negative 2x plus 5y should equal negative 10. Filling in what we know now, x is 5, so I'm going to fill in the x with 5. I'm going to fill in the y with 0 equals negative 10. Negative 2 times 5 is negative 10 plus, this is 0, equals negative 10, and negative 10 does come out equal to negative 10. So it checks out for the first equation. Now equation number 2. I know you can't see it on the screen, but you've got it on your paper. Equation number 2 was 2x plus 2y equals 10. So that means I would have 2 times 5 plus 2 times 0 should equal 10. 2 times 5 is 10, 2 times 0 is 0, and 10 plus 0 is 10. So that works out for the second equation. We know we're right. Let's go ahead and look at the back of this now, the second page. Let's look at this one, number 5. We've got negative 5x plus 10y equals negative 30, and 5x minus 8y equals 26. Adding them together, we see negative 5x plus 5x is going to cancel to 0. 10y minus 8y is going to give me 2y, and negative 30 plus 26 is going to give me negative 4. Now all I have to do is divide both sides by 2, and we get y is equal to negative 2. All right, we already have part of our answer. We have the y. Now for the x. I see a whole lot of negatives and stuff here, but I'm going to be plugging in a negative 2 for y. I guess it doesn't matter. I'll just use the top one. Negative 5x plus 10. I'm going to leave a spot for the y equals negative 30. We now know that y is negative 2, so we fill that in. We get negative 5x plus negative 20 is equal to negative 30. Draw the line, circle a variable. We need to get rid of this negative 20. To do that, we're going to add 20 to both sides. Add 20. So now we have negative 5x is going to be equal to negative 10, and dividing by negative 5 gives me positive 2. So now we know x is positive 2. We check for both equations. Equation 1 was negative 5x plus 10y equals negative 30. That means I should have negative 5 times 2 plus 10 times negative 2 should equal negative 30. Negative 5 times 2, is negative 10, plus negative 20 should equal negative 30. These are both negatives, so I combine them together, and it does come out to negative 30. So I know it's correct. Equation number 2 was 5x minus 8y equals 26. So I check. My x is 2 minus 8 times negative 2 equals 26. 5 times 2 is 10. Negative 8 times negative 2 is positive 16. Should equal 26. And 10 plus 16 is 26. Okay, so that worked out. These are all of our easy ones. Now on to this one. Look at number 6. So number 6, if we add these together the way they are, we would get 10x, but negative 1 plus negative 1 is going to be negative 2y equals 30. Well, that didn't eliminate anything, and so we've got to change something about one of these. Notice the ones that eliminated had opposite numbers in front of the same variable. Positive 1, negative 1. Positive 1, negative 1. Negative 2, positive 2. So we need them to be opposites. We need opposites. We need opposites. We need opposites. So I'm going to erase this because that is not opposites. We did not have opposites already. Nothing eliminated, which means we need to do some more work. In order to see more work, there is going to be a part 2 to this video. It won't be too long, just a few more minutes to explain this part. Please go ahead and stop the video after this and go on to part 2.